Alright, so in this lecture I want to talk about the input file modes and the output file modes. We can specify a mode when we open a file or associate a file with an input or output stream. So in this case, we can see with the input file modes, previously we did not specify a mode. We have IF stream, we are declaring an IF stream called infile, and then we are specifying some input file name .txt, and then we can provide a mode such as standard iOS-IN, for example. Now that is actually the default, and because of that we can simply specify the file name, as we have done up until this point in the lesson. For input files we can also specify binary, and that is then going to read binary, or in other words open the file in binary mode. For output file modes we are concerned with more of those modes. For example, the default is standard iOS out. Alright, so that is specified if we only provide the file name with the OFStream object. However, we can also specify trunc for truncation, app for append, ATE for at the end, and then also binary for binary mode. So I've summarized that here in this table here. We have a constant, in for opening file for input, so reading in other words. That is the default for the IFStream objects as I mentioned, and then out for opening the file for output, or in other words writing, and that is the default for OFStream objects. Then we can also specify trunc for truncation, in which case the existing file contents are truncated, or in other words discarded. And this is implied if iOS out is specified but not iOS in or iOS app for append. With the append constant, all output operations are appended to existing contents at the end of the file. So in this mode, we are not truncating, we are appending to existing contents. Alright, so that is very handy. You might have thought about whether or not that is possible, and in this way, in this lecture I will demonstrate how we can do that. Then we have two modes that we are not concerned with all that much. We have ATE for at the end, so it will set the initial output position, or in other words the typing caret basically, or the output caret or pointer to be at the end of the file when opening. And then we also have binary as I mentioned, and in that case operations are performed in binary, or in other words ones and zeros, right? Of course I demonstrated this using the constructors, but this also applies to the open function. Alright, so a quick example, I'm including a couple of things here: iostream, fstream, C standard library for exit, and then string. As I mentioned, you don't really have to include C standard library when you include fstream, but I'm doing this here just for clarity, and it may be a good habit to include that for the exit function. Alright, in main we have an instream object, an ifstream object, instream, and this is going to open this file right here, tasks.txt, and we can open that in this mode, standard iOS-IN. Alright, and the tasks is going to include some tasks here: feed the dogs with a new line, and then feed the chickens. Alright, then I'm going to open that, check if that is open. Then I also have an output stream, OFStream object, outstream, Bob's to-do list.txt, and I open that in out mode. Also, if you do Ctrl space bar here, notice that this parameter has this mode for the second formal parameter. Alright, and the same thing with input. In the ifstream constructor here, for example, you also have this open mode, standard iOS base open mode, and for outstream we have the open mode as well. I check if the outstream is opened, and opened successfully. Then I have this line string, and while we do getLine here, instream line, and I'm going to write those lines that are in the tasks here, list here, out to the outstream. Alright, then I close those off. So we should not see much here when we build a run other than end of program. I will build a run. We get end of program. I will right click on the project, and then click to open the file in the File Explorer. Click on Bob's to-do list, and we get feed the dogs and feed the chickens. Now as I mentioned, these are the defaults where we've seen that before. So if I remove that, build a run, once again we get feed the dogs and feed the chickens. Now sometimes we may want to append So I will undo a couple of times. We have standard out, and we can also append. So we can do append like that, app for append, build and run. So it has appended the contents to the existing contents in the file. So we get feed the ducks, feed the chickens twice. And that will continue. If we build and run again, and notice we get that 3 times now. And then we also have trunk. And if we build and run, it will truncate, or in other words discard the previous contents before it will write out these contents here. Now I'd like to note that we can specify multiple modes. So for example, we can do standard iOS trunk along with out. So for example, we've seen this kind of syntax before. Okay, we can specify multiple modes using the bitwise OR. Do not use a comma. Use this vertical bar, the bitwise OR. So we open this particular file for output, and we also want to append, alright? Build and run. And we have appended, as we can see here. In the next section, I want to introduce the seekp and tellp functions, since we will use those to set and get the position in the output sequence, and we will use those to demonstrate the @e option that we have discussed previously. So again, we can set and get the position in the output sequence or the pointer in the output sequence or stream using these functions. The function standard ofstream seekp is used to set the output position in the output stream, and then tellp is used to get the current output position or pointer. We see some simple examples here. seekp can take in an argument, so we pass in the position to set relative to the beginning of the stream. We can also pass in 2 arguments to offset relative to the way parameter. The way parameter relates to where we start, so do we start at the end or the beginning or the current location in the stream. Then we can also return the current stream position using tellp. Here are some of the constants that we can pass the seekp. That is for the way parameter, so we can pass in iOS space current, cur for current, that is for the current position in the stream, end for the end of the stream, and then beg for the beginning of the stream. And then, as I mentioned, we have the first argument is going to be the offset, so the offset is then relative to that way parameter. Right, I've modified the example a bit. I have this iOfstream instream, and I'm going to open the tasks.txt. The tasks.txt will contain this party invite Bob. So we want to invite Bob to the party. Again, I'm still making sure to use the appropriate includes here. Next, I again check if that is opened successfully. And then I have the ofstream outstream. This time I will open a file called completed to-do list. I will open that in the out mode. Again, those are the completed tasks that will go in there. Just a silly example, alright, so then I make sure that the outstream is opened successfully and connected to successfully. Next I have this string line, which we can use to get the line and pass in stream and line, and then we can put that line out. So we can insert line into outstream. I'll just comment that out here for a second. Next I will do outstream.seekp. So we want to set the pointer, basically the output position or caret, to a specific point in that output stream. I use 14 here, that is just based on where I want to start, because basically you can think of this as being the caret, right? The typing caret, where you will put that, and that's basically going to be in insert mode, which we have discussed previously. So it's going to overwrite where it starts typing at, or where it starts to insert data, it's going to overwrite. So if we insert this whole mob here, it's going to overwrite this Bob here, right? Then I'll close those. And so before we do this, if I comment all of this out, build and run, and I open that completed to-do list, we can see party invite Bob, alright? So we have invited Bob to the party. Now if I uncomment these two lines, we can seek and we can do the wall mob build and run. Now we get party invite the whole mob. So instead of inviting just Bob, I invited the whole mob to the party. Alright. What we can do now is where we do the opening of the output stream. I'll begin the demonstration with app. So for append, we have standard iOS out and then we have append. If we build and run now, inspect the completed to-do list, notice that we get party invite to whole mob that was there previously from the previous run of the program. Next we have party invite Bob and then the whole mob. So this doesn't seek as we would expect, so the seek doesn't quite work as we want. So what we can do is we can use ATE instead. Alright, so now we may expect this to work kind of in the same way as append. We may expect this to not truncate and sort of get rid of the previous contents in the file. But if I build a run, notice that we do get party invite the whole mob, but we do not want to truncate, right? We want to keep the previous contents. So one way we can do that is to change out to in. That's one sort of hack that you can do. So we have in and ATE. And now we get the whole mob at first, and then we get party invite Bob. Remember now that this is going to change the file contents or set that pointer from the start, alright, not from the end, but from the start. That is why we have party invite the whole mob here, and then party invite Bob is not going to change the second line, it's going to change the first one. So we can change that. We have this seek p here. We can use the one with 2 arguments, and you can decide. So here we want to decide how many characters we want to move back from the end. So let's go with -5, for example. Instead of adding 5 to the end, we want to subtract 5. So we want to move the typing caret basically, or that pointer, to the left instead of to the right. And in that way we will overwrite this Bob. So if we move the typing caret to over here and we start typing, it will overwrite what is in that space here, right? So let's choose -5 here for the first argument. For the second argument, we can specify end, so from the end. Alright, so now it's going to seek to the end, and then it's going to go left 5 spaces, basically 5 characters, and then it's going to insert this into that output stream. Build and run, and let's see what we get. Now it's going to go to the end, and then it's going to insert that. So, and it's also not going to truncate, it's going to append basically. And then in a similar way, we can do this sort of calculation. I'm using long here, position, long. I'm converting this here to long, so I tell p, I get the current position, which should be at the end because we are using this at the end, right? Then instead of doing this, we can do something like this, position -5. Build a run, let's see if that works. And as you can see, that basically does the same thing. It's going to move the output pointer, so it's going to get the location of the output pointer. We convert that to a long, and then we are going to subtract 5 from that. So it's going to be at the end here, right? Then we subtract 5, which the statement would have looked like this with Bob here. Then we move it back, and then we insert the whole mob into that. Otherwise, if you go and remove this, if you simply put in the position like that, and then you insert, you can think for a second what's going to happen. As you can see, it's not going to overwrite Bob anymore because we don't move that caret back. We don't move that pointer back. We simply insert the whole mob at the end. And again, if you use out here instead of in with the ATE, the at the end, if you use out, then again it's going to truncate, so it's going to replace the previous contents, which may or may not be what you want. Okay, so that is going to wrap things up for this. I just wanted to introduce the seek p and the tell p, because this should give you a better understanding of the ATE as compared to the append. And with the append, we cannot move that typing pointer to seek, but with the ATE we can. All right.